Hi, and welcome again to the CDFM study group. My name is Helen Thomas. We're going to be continuing the review of CDFM Module 2.2, Cost and Economic Analysis. And we will pick up on page 2.2.21, where it talks about the life cycle cost. So again, now we're focusing on that cost analysis and understanding what makes up cost, because we have to look at that total cost concept. We need to understand from that, what they say, cradle to grave, from the initiation of that requirement and that equipment to when we demilitarize it or we demolish, we get rid of those items. So life cycle cost has three categories. It talks about the appropriation category. This method of grouping life cycle costs is the greatest interest to the business. Financial talks about a different category. So first of all, we put it in the appropriation category. We want to know which type of appropriation do we need to perform this function. You put a dollar amount on it, so you know how much O&M to ask for, how much MILPERS, and so forth. The second part on page 22 is the work breakdown structure, and we talk about WBS. This method is grouping life cycle costs is of greatest interest to the program manager, because the program manager will know based on a particular job or function, this is how much it costs to perform that function. So work breakdown structure, associate price with that. The third is the life cycle cost categories. So the categories is either research and development, investment, operation and support, or it's a disposal type account. So those are the four life cycle cost categories. So we're still talking about the acquisition one programs. There are required life cycle cost estimates for the acquisition programs. So for acquisition category 1 programs, there are 3. So the initial cost estimate that's done in the program management office, that's run by a program office executive that has program managers working for them, the POE, program of office estimate is conducted at the initial stage. Then the second estimate, once it gets to, let's say, the Army, the component cost estimate is done. The third estimate of an acquisition category 1 Delta program, so even though the milestone decision authority is at the DoD level, if it's a requirement for the Navy, well, Navy personnel component cost personnel will then do the second estimate, how much it's going to cost. So program manager's office does the program office estimate. Your component acquisition or cost person does the component cost estimate. And the third one, estimate for the acquisition 1 Delta program is normally done at the OSD level by the director of CAPE, DCAPE, because that's the top cost person at the DoD level. Let's read on. This estimate, so this organization is not in the acquisition community, director of CAPE, and is independent of the acquisition chain of command. This estimate is known as the independent cost estimate. So the director of CAPE, who specializes in cost management, cost analysis, will do an independent cost estimate on the same requirement, and then they compare. So normally only the first two type of estimates for acquisition category 2, 3, and 1 AC, normally only the first two type of cost estimates are done, because if it doesn't need to go to the DoD level, then you don't have to have the director of CAPE doing a cost analysis. All right, another section on page 2.2.24. Now, what makes up the life cycle cost composition from your cradle to your grave? And so I will advise that you would take this section by itself because you have multiple parts within here also. So as you can see with the diagram on the top of page 24, that life cycle cost. The life cycle cost is that huge, the big square that surrounds number 1, 2, 3, 4, 5, and 6, where it talks about development costs, number 2 being your flyaway costs, weapon system costs, procurement, your program acquisition costs, program spares, operation and support, disposal. So let's look here. So development cost is your RDT&E. It's important for you to know this because you will, let's say they tell you, all right, how do you calculate the flyaway cost? And you're like, oh my God, what's flyaway? So they'll give you the values for each one of those, but then you will have to calculate the flyaway cost, let's say. So let's look at each one on page 24, because you notice it's not listed out in the material itself, but it's essential for you to understand. There's a diagram on page, or a chart on page 26 that explains what each one of the terms mean. But I love pictures because you're able to better remember where things are. So let me take my page out so I can at least look up at you. All right, so development costs. So think of the initial cost. We talked about we need RDT&E to do our research. So development cost is your RDT&E. Makes sense. Early on in the process, we're developing the system. We need research, development, technology, and equipment, RDT&E fund, appropriation. Number 2 is your flyaway cost. Now that we've done the research, we are ready to fly away. Flyaway cost is procurement of the prime equipment, the main part that we need. We're not talking about the extra wrenches, the extra tires, the spare parts, support items. We're simply talking about the prime item. So again, development costs, RDT&E funding. So if I have a list of RDT&E, Milcom, procurement, O&M funds, and they say calculate the development cost, well, my development cost is simply I need to take my RDT&E dollar amount. That's my development cost. Then once I develop and I am approved to move on, I'm ready to fly. Flyaway cost. That is my procurement of the prime equipment. Now, when I add procurement of support equipment to the flyaway, that then becomes number 3, the weapon system cost. Trying to make sure we grasp this. So procurement of the prime item alone is the flyaway cost. When I add procurement of support, that's the weapon system cost. Number 4, when I add procurement of initial spares, that is called procurement cost. And just that means everything that had the word procurement on it makes up my procurement cost. Because ideally, you're going to have to calculate these things for yourself. And it's basically you get a list of all these costs, and you're going to have to, calculate the program acquisition cost. That includes my military construction cost, my development, see the little small dotted square? My procurement acquisition cost includes everything inside of that dotted square. So my RDT&E, my Milcon, and my procurement make up my program acquisition cost. And then number 6 is my operations and support. My operations and support is O&M, MILPERS, and it says disposal, use O&M or other as appropriate. So for operation and support, I need O&M and MILPERS funding. And this also ties into that whole acquisition system that we talked about, the process from pre-systems acquisition. We talked about using RDT&E money. So development, so let's see if we can walk through it. Let me see if I can do it without looking. I don't know. All right, so development costs, I use RDT&E funding. Once the system has been approved for development, then I'm ready to fly away. Fly away cost requires procurement of the prime equipment. When I add procurement of the support, when I add procurement of the support items, then that becomes my weapon systems cost. When I add the other procurement of the spare items, that is the procurement cost. When I add military construction to that whole RDT&E procurement and military construction makes up my program acquisition cost. The life cycle cost, when I take my program acquisition costs, I add my operations and support, which is my O&M and MILPERS, and all those costs together make up the life cycle cost of that item. Make sure you continue to play around with that on page 24, because again, you have practical exercises you have to accomplish. So you have the definition at the bottom of 24 of a program acquisition unit cost. So we talked about program acquisition cost, that's the total package. But if I give you the total items, it's saying you need to calculate for one item, the unit cost. So whenever you see unit is what's the price of one, then you can come up with an average procurement unit cost. So we're going to look at each one of those, but the procurement in this second one on the bottom of 24 tells you that you're only using your procurement numbers to make that calculation. The program acquisition unit cost, because if you take the unit out, that's your program acquisition cost. We just looked at the diagram, includes RDT&E, procurement, and military construction. So you have some examples at the top of page 25. Let's review those. Example of procurement acquisition unit cost. So you have the number of units and the cost in thousands. So RDT&E cost for the prototype is 1 at 5,000. Procurement funding for additional 199 units cost 20,000. Milcon funding for unique facilities 1,000. So your total units is 200, and cost in thousands total to 26,000. So unit cost means you have the total. So program acquisition, so be careful, because if you get an example of similar to that first one on the top of page 25, and they include the values for O&M and the values for MILPERS, you will have to know that you have to take those values out to calculate the program acquisition unit cost. Do not think that on the test that they're only going to be giving you the numbers that you need to use to get your calculation. Chances are you're going to get a wealth of information that you don't need, and you're required to pick out, just like in your office. You get more information that you need, and it's up to you to determine what is valid and what is required for you to do the calculation. So that means you need to know what it takes to calculate your program acquisition cost. But for this instance, they only gave you the RDT&E procurement and Milcon. Your total units 200, your total cost 26,000. So to get your unit cost for one unit is your 26,000 divided by the 200 units you're creating, and you have a total of 130.5 thousand. All right, and so the calculation at the top of page 25, the program acquisition unit cost is 130.5 thousand. And also an example for the average procurement unit cost. So procurement, so for example, the second one, let's say they gave you the RDT&E of 1. They also gave you the military construction information. You would then have to know for the average procurement unit cost, you then will only be required to pull out the procurement number. So if in this instance, they only gave you the procurement, and so you take the 20,000 divided by the 199 to give you 100.5 thousand. So that's your program acquisition unit cost and your average procurement unit cost. And understanding your life cycle cost composition is going from acquisition from cradle, your development, to grave, which is your disposal. And as mentioned on page 2.2.26 are the definition, the terms, the explanation, the types of appropriation, and the life cycle cost categories. Remember, we talked about RDT&E investment, operation and maintenance, operational and support, and other categories for your disposal. So that's an awesome chart for you to ensure that you review. Page 2.2.27 talks a little bit more about the work breakdown structure. You see example at the top of breaking the work down so that you can actually get the cost associated with each one of those functions. So one of the most important initial actions taken by both the government program office and the contractor firm awarded a production contract is to the development of a work breakdown structure. Work breakdown, WBS, is a product-oriented family tree. And you can read through that and you see the diagram, so I'm not going to spend a lot of time on it, where you actually can see the information. Provides a common thread for earned value management. I'm reading at the bottom of page 27. And the integrated master schedule. So it's just making sure that your timeline and your workload, your schedules, all are in line with your costs to get the job done. More work breakdown structure on page 28. All right, cost is an independent variable on page 29. We touched on that before. So the cost is an independent variable is based on the principle that the best time to reduce cost is early in the process. And I think I mentioned this earlier. So the CAIV is essential for your planning processes to making sure that we know exactly that life cycle cost, cradle to grave mentality of how much it costs to make that purchase. So on page 30, cost analysis used in the acquisition process. It mentions again your director of CAPE. The cost estimate is used to make programmatic decisions to help that milestone decision authority determine if to go to the next phase or not. There are different types of cost estimating method, and I guarantee you need to know these because everyone who've taken this test tells me, yep, I had to select a cost estimating method, and it's typically a scenario based on how you calculate. So it's not going to be a direct definition of the word, but based on understanding what analogy means, parametric engineering actuals, and your expert opinions, what they mean, you'll be able to then decipher that out of the scenario. So cost estimating method number one, analogy, is that means you're trying to come up with what does it cost to make this purchase. So analogy approach is getting historical data from a similar system to the one that you're trying to develop. So you can use historical information for one similar system. Analogy, you think of that as like history, right? Analogy. So the second method is your parametric. Metric means statistic, top down. Those are all the words mentioned in numbers, page 32. Parametric use historical data from similar multiple system, and then you kind of come up, use the multiple system, you compare the cost, and then you kind of come up with the cost for the one that you're trying to develop. So analogy, use the historical data of one other similar system. Parametric, which is your statistical top-down, using statistical data to calculate based on multiple system. This is what it will cost to develop this other system. Number 3 on page 33 is your engineering approach. And then you read through that where I said statistic was top-down approach. Engineering is considered a bottom-up. It's the most detailed because you think of an engineer, we're trying to actually analyze the intricate details of that equipment or purchase that we're trying to accomplish. So an individual cost estimate must be accomplished for each work breakdown structure, and the engineering approach may be used if you have that time. It's most detailed. So detail also means it's going to take a lot of time to accomplish. Number 4 is the actual cost. That means I already have a system already in development. I need to develop some more. I have an actual cost of an actual system, actual cost. Using expert opinion simply means you get a bunch of subject matter expert and you use on page 35, you look at the bottom, it talks about the Delphi technique. It's based on what your input you receive from the subject matter expert is you then look at patterns. Which one do they agree on? And then by a consensus, it's like a opinion-based, what they say, subjective judgment. So you don't want to use expert opinion if you have the time to do a good analysis. Again, we're talking large dollar amounts that decision makers have to decide if they want to continue in this development. So expert opinion may probably not be a good idea if you have the time to do the research. All right, let's go to page 2.2.36 as we get ready to talk about the learning curve theory. So the learning curve theory, I'm reading at the second to last paragraph on that page, says the learning curve theory implies that as the quantity of production doubles, the labor hours per unit expended to produce the product decreases. So that means the more you do a job, the learning curve, so I'm paying for manpower, labor hours, implies that the quantity of production doubles. I'm producing more the longer that I stay on a job, and producing more within less time or the same time frame. So the longer I do the job, because I'm becoming an expert at the job, I now can produce more. So labor hours is calculated, it's a part of your manpower hours or labor, the cost of labor is incorporated in your cost analysis. I know it's a lot, so hang in there, don't give up. So I'm going to jump over to page 37 and let's give it has an example of the learning curve application. So learning curve theory is simply a scientific way of determining how much learning should occur and applying this to a production estimate. How much time, when you first start a job, you know that you're a little bit slow, but as you start learning the job, the idea is your production should increase. You should be producing more. So for example, which is the second paragraph under DoD, examples of learning curve application, tactical missiles follow an 85 to 92% learning curve. This means that every time the production quantity of a particular tactical missile doubles, for example, from Unit 8 to Unit 16, unit labor hour is reduced to 85 to 92% of the previous unit's labor cost. This is an 8 to 15% cost reduction. So it's costing me less because now you're producing more items. So in other words, the cost to produce Unit 16 is anywhere from 8 to 15% less than the cost to produce the 8th unit. So it's going to cost me less each time I double my production. So type 1, so there are two types of calculations to calculate the learning curve. So we're going to go with the example, given the time required to produce Unit 2, and you're going to have to do examples like this. So they'll give you the unit, and then they'll ask you, well, determine the hours that it'll cost to produce from unit number 4 and 8. So solution requires multiplication. So what it is, so unit 2, we said is 300 hours, and we said the learning curve is 90%. So if you multiply 300 hours times 0.90, which is 90%, you should get 270 hours. So produce unit 2, it will then take, let's see, unit 2, it takes 300 hours. But to go from unit 2 and double to unit 4, it's only going to take 270 hours. But it also says go to unit 8. So we'll start with unit 4, which is 270 hours times the 90% learning curve is 243 hours to produce unit 8, and so forth and so forth. And you can continue this process. So this type of calculation is useful when determining the estimated cost of production lot of a specific quantity of items. The type 2 is you may then be required to calculate what is the learning curve rate, that percentage that was given before. Now you may have to calculate it. So it says, given the production times of the following units, determine the learning curve rate, and the solution requires division. So it's kind of working backwards. So unit 2, we said here, this example on page 2.2.38, it takes 250 hours. Given is unit 4, takes 237 hours. So how do you think you calculate the learning curve rate? So if you divide the 237.5 divided by the 250, you should get 95%. So whenever you're trying to get a percentage, it means you have to divide the smaller number. Let me do that, 237.5, and making sure divided by 250 equals 0.95. And the good thing is when you're getting the learning curve rate, the rate should be the same for all the problems. So to check yourself, you do the same thing. Divide 225.6 divided by 214.3. You should get 0.95 for all of these on page 38, which means that the learning curve rate for these values is 95%.